Okay, let's go ahead and take a look at integration by parts. Now before we go ahead and talk about this particular technique, let's go ahead and take an inventory of the integration techniques that we know so far. For one, we know the U substitution, which we said was the inverse of the chain rule. So whenever we have the differentiation of a composite function, if we wanted to go ahead and integrate that result, we again use the U substitution. We said that the U substitution could also be used for integrals that look like the integral of x times it by the square root of f of x d of x. Okay, and then we also talked about trig substitutions, and we said that if your integral has something of the form a squared plus x squared, or the square root of a squared plus or minus x squared, then if you use the particular trig substitution and the Pythagorean trig identities, then you could come out with a very simple integral that could then be integrated, and then you go ahead and resubstitute into the value of x so that you could go ahead and determine what that integral looks like. Okay, and then what we're going to add to that now is integration by parts. And just to put that in perspective, integration by parts is really basically the inverse of the product rule. So before we actually go ahead and take a look at what that looks like, let's go ahead and review again the product rule, and we want to actually make sure that the product rule actually has a particular form that will be more presentable and easier to understand in terms of the integration and the inverse process that's involved. So let's just go ahead and take a look at two functions u and v, and let's say that these functions are in terms of x and are completely integratable and differentiable. Then what we're going to say then is that if we take the derivative of uv, or the product of u and v, with respect to x, then what we're going to come up with is u times it by d of v over d of x plus v times it by d of v over d of x. Now what I'm going to do is I'm going to simplify this form just a bit, and I'm going to say that this whole derivative here is just going to be denoted by the product of u and v prime. So the derivative of the product of u and v is going to be equal to u times it by v prime, because that's what d of v over d of x is, plus v times by u prime, which is d of v over d of x. So this is the form here that I want to pay particular attention to, because when we go and take a look at integration by parts, of course what we're going to have to do is we're going to have to integrate both sides of that equation. So let's go ahead and take the integral of both sides with respect to x, and notice that what we have is we have the integral of the derivative of the product of u and v with respect to x, and then of course the same thing for these two parts here as well. And if we think about what's happening here, you got the product of two functions, you're taking the derivative, and then after that you're taking the integral of it. So basically those two are undoing each other because differentiation and integration are inverse processes of each other. And so we know we're just going to come out with u times v. And this side over here is just going to be more or less the same. Now, what we're going to do is we're going to just go ahead and solve for uv prime d of x by just subtracting this integral from both sides and coming out with this. And this right here is actually going to be the form of the integration by parts. Okay, so now how do we actually go about using that? Now, before we go ahead and use that, let's first establish what we have and what we need, because this form is just slightly difficult to understand if you don't know exactly what you're dealing with to begin with. So let's go ahead and take a look at it. This right over here is what we're trying to accomplish. Okay, so if that's the case, then basically the problem that is going to be given to you is actually telling you what u and v prime are. So we need to go ahead and establish what u and v prime are. After that, in order to go ahead and determine what this particular integral is going to be, then we need to know what u prime is, and we also need to know what v is. So once we establish what u and v prime are, given by this problem here, then we need to go ahead, given u, what is u prime going to be? Given v prime, what is v going to be? So notice in this particular situation here, for the relationship between u and u prime, you're finding the derivative. But for v prime and v, you're actually integrating. So you need to be very careful about following the process very, very carefully there. Otherwise, it can go haywire very, very easily. Now, let's go ahead and take a look at a concrete example. Let's say, for example, we have the integral of x e to the x d of x. Okay? Now, if we go ahead and just try to take a look at some of these other substitutions and other techniques that we have, there's nothing that we can actually do for this. Okay, we can't do a u substitution. There's no trig substitution that's going to work because this doesn't have any kind of form that would lend itself well to trig substitutions. And so what we're going to do is we're going to try to integrate this by parts. Now, if I go ahead and take if I go ahead and say that u and v prime, let's go ahead and say that u is going to be x and v prime in that case is going to be e to the x. Then what I need to find then is what is u prime? Well, if u is going to be equal to x, u prime is going to be equal to 1. If v prime is equal to e to the x, then v is equal to e to the x. So what I come up with then, by just following the integration by parts, is that the integral of x e to the x d of x is just going to be equal to uv, which is this times that. So x times it by e to the x, minus v times it by u prime d of x. So what I have then is 1 times e to the x d of x. And we know that this is actually just going to be e to the x plus c. So there you have it. You have the integral of x e to the x d of x is going to be equal to x e to the x minus e to the x plus c. Okay. Now, what the key then is going to actually be, in order to solve this types of questions, is the proper establishment of what u and v prime are. Now I'm going to go ahead and take a look at this exact same problem, the integral of x e to the x d of x, and I'm going to go ahead and associate x with v prime and e to the x with u, and watch what happens. Now if I go ahead and I say, okay, u is e to the x, then u prime is going to be e to the x, of course, because if I take the derivative, it's just going to be e to the x. Now notice if I have v prime being equal to x, I integrate that to come up with v, and I come up with 1/2 x squared. So if I go ahead and use my expansion now for this particular integral of u v prime d of x, which is this right here, I'm going to come out with x e to the x minus 1/2 x squared e to the x d of x. What's happening here is it's getting more complicated. So it's going to be absolutely critical then for you to be able to establish which would be the best form of, which would be the best association of u and v prime. Now generally speaking, of course, the derivative is going to make things more simple, especially if you're dealing with a polynomial. So you want to go ahead and kind of look at it from that perspective. But it's not always going to be the case, and there's going to be some other little tricks that we want to go ahead and look at, but that's just going to come with experience and with trial and error. Now, I would like to go ahead and invite you to go ahead and try this one here. We have the integral of x squared natural log of d of x. Okay, think about it. What would you let u be? What would you let v prime be? Think ahead and see whether or not what you come out with here is actually going to be something that is going to be integratable. If it is, then go for it. If it's not, then you may need to go ahead and reassess whether or not your initial establishment of what u and v prime are is the correct one. Okay, so let's go ahead and summarize then. We have a couple of integration techniques here. Integration by parts is going to be the inverse of the product rule. Okay, we know that we need to go ahead and use this as integration by parts. We need to establish what the proper u and v prime are, so that in the end, what we can do is we can actually go ahead and integrate this integral here to come up with the overall integrand there. Okay, now, last thing that I hope that all of you recognize is that when it comes to all of these functions that we've seen in terms of the examples, we have 1, a polynomial, and 2, a transcendental. If you have the product of those two, or if you have a transcendental times a transcendental, then you really need to go ahead and look at integration by parts in order to solve for the integral. Okay? So we'll take a look at some examples and see you later. Bye-bye.